Earth is a bustling, vibrant system of life. A quick hop over to our planetary neighbor offers a completely different reality. Mars is a desolate, freezing wasteland swept by toxic dust storms. Yet, by the year 2050, this hostile environment is slated to become humanity's second permanent address. For years, the conversation about getting there was dominated by Western space agencies and privatized flight. We constantly hear the loud, ambitious visions of NASA and billionaires like Elon Musk pushing to make human life multi-planetary. But while the West dominates the headlines, China has been methodically executing its own quiet roadmap. Their Zhurong rover recently touched down, making a massive discovery under a region called Utopia Planitia. It found clear geological evidence of ancient floods, and more importantly, radar data pointing to vast deposits of frozen water just beneath the surface. This diagram highlights the immediate problem with that surface. Mars lost its magnetic field billions of years ago. Without it, solar radiation bypasses the dead core and bombards the ground constantly, shredding DNA. Add in an atmosphere of 96% toxic carbon dioxide and nighttime temperatures plummeting to negative 140 degrees Celsius, creating a recipe for instant death. The move to Mars has evolved into a high-stakes engineering war. Superpowers are racing to see who can first build the specialized infrastructure required to sustain human life on a world with zero margin for error. To prepare for that reality, China has taken a unique approach right here on Earth. Long before they launch a human crew, they are conditioning their people by building extreme simulation camps like Mars Base 1. Set deep in the Gobi Desert, this analog facility is designed to replicate the brutal isolation and barren landscapes of the Red Planet. It turns out, perfecting the rocket engines is only half the battle. The true bottleneck of early colonization is whether the human mind can withstand absolute, inescapable isolation. Getting to Mars requires surviving a 9-month journey through irradiated space, but the single most dangerous moment happens right at the end. NASA engineers call the atmospheric entry process the 7 minutes of terror. The physics problem is that Mars has an atmosphere 100 times thinner than Earth's. There is just enough air to create blistering heat against a spacecraft, but not enough drag to naturally slow down a massive payload falling from orbit. To solve this, aerospace engineers have developed a range of wild solutions. NASA has used giant airbag clusters and rocket-powered sky cranes to gently lower small rovers, while SpaceX is betting on firing massive retro rockets to decelerate their heavy Starship vehicles right before impact. Soft landing is the ultimate filter of space exploration. If these nations cannot figure out how to safely drop thousands of tons of cargo and human beings onto the dirt, every grand colonization plan instantly turns into expensive crater debris. Once a crew actually lands, they need shelter immediately. But hauling heavy steel and concrete across 140 million miles of space is an economic impossibility. This forces every space agency to rely on in situ resource utilization, or ISRU. That is a technical term for a simple concept: building infrastructure using only the raw materials you can scrape off the local Martian ground.
Looking at this diagram of a proposed habitat, we see NASA's approach to ISRU. They plan to send AI-driven robots ahead of humans to 3D print shelters out of the local dirt, known as regolith. By wrapping these structures in solid ice, they create a shield that blocks cosmic rays but allows sunlight in. China is taking a different route, melting local regolith at 1,000 degrees and mixing it with sulfur to forge ultra-durable bricks. Mastering these robotic construction methods is a prerequisite for long-term survival. The nation that can build reliably using only Martian dirt will hold a massive strategic advantage, finally breaking the tether to Earth's expensive supply chains. Building the walls is step one, but the inside of those shelters must hold an immense amount of pressure. Because the outside atmosphere is nearly a vacuum, any sudden depressurization would cause the liquids inside a human body to literally boil. Inside that pressurized bubble, humans will need a closed-loop hydroponic greenhouse to grow food. In a system like this, nothing can be wasted. Every single drop of moisture, down to human sweat and urine, has to be captured, filtered, and pumped back into the plants. To secure breathable air,
the colony will have to rely on advanced chemical engineering. This means deploying heavy machinery to crush raw Martian rocks, extracting the trapped oxygen from hydrated minerals and ancient volcanic deposits. When your closest supply chain is 9 months away, waiting for a rescue ship isn't an option. The base has to operate as a flawless, self-sustaining artificial biosphere, or the entire colony perishes. Even with perfect shelters and endless food, the planet itself will exact a heavy biological toll. Mars only exerts 38% of the gravity we feel on Earth. This reveals what lack of gravity does to the body. Early colonists will experience severe reductions in bone density, weakened cardiovascular systems, and muscle atrophy. Over generations, these changes become permanent. Mars-born humans will develop elongated, thinner skeletons to adapt to their low-gravity environment. We will leave Earth as humans, but the unforgiving physics of our new home will forge our descendants into an entirely new, alien species. So what is the ultimate endgame of all this risk and biological sacrifice? For the West, the grand vision is terraforming. Proposals range from placing giant solar reflectors in orbit to detonating nuclear weapons over the poles, all in an attempt to melt the ice caps and generate a breathable atmosphere. Contrast that with the highly pragmatic vision coming from the East. China's long-term focus leans toward constructing vast subterranean mining colonies. Their goal is to tap into untouched veins of rare earth metals and dominate the future of interplanetary trade. Extracting and moving those resources at scale requires massive hardware. That is why the immediate priority for these agencies is developing and testing next-generation heavy launch vehicles capable of deep space transport. Looking ahead to the year 2050, the red dot we have stared at in the night sky for millennia will transition into humanity's very first extraterrestrial address. The hostility of Mars isn't stopping colonization, it's accelerating it. As nations solve the puzzles of bone density, radiation shielding, and resource extraction, they're laying the groundwork for a geopolitical landscape that extends far beyond Earth's atmosphere.